Hey guys, John here from San Diego Miramar College, the Advanced Transportation Department. I've been here for about 5 years. I'm the instructional lab technician here. Thank you for joining us. Today we're going to be going over what parasitic draw is and how we diagnose it. Parasitic draw or drain is a term for electrical components consuming electrical energy when it should not, even after the vehicle has been shut off or key is off. So generally 50 milliamps is too much parasitic draw. This will cause the vehicle's electrical system to function improperly, and the vehicle may exhibit one or more of the following symptoms. 1. A persistently dead battery. Or 2. The engine may not crank over at all, or it may crank over slowly. Generally, this happens within a 12 to 24 hour time span of the vehicle sitting overnight. 3. So what can cause parasitic draw? Generally, the most common cause is a customer-related issue. So they will leave their headlights on, or they'll get out of their vehicle after a long day of work and they'll leave their dome lights on and just close the door behind them, lock their car, and that light is just left on overnight, causing the vehicle's battery to die. Number 2 is generally aftermarket-related systems. So if you have an aftermarket alarm or aftermarket audio, this could also cause that. For example, an aftermarket audio system could be wired with key off, but the system will still be live. So the amp will be on, still powering the base, and therefore will cause a slow drain overnight. The third reason could be just a simple software update. The vehicle's navigation system is not updated, so that'll cause the system to be on overnight and also cause the vehicle's battery to drain. Lastly, a computer not going to sleep. This is one of those weird things where a computer in the vehicle will not go to sleep, such as the body electrical, and that could also cause a slow drain overnight. So how do you diagnose parasitic draw? We'll be going over 2 methods, but before we even get to diagnosis, we have to prep our vehicle in order to get accurate results. So the first step is make sure the battery is charged. Weak batteries do not give accurate results. The second step is verify that the charging system is operating properly. If you have forgotten, please reference our other video segment on charging systems. Step 3, turn off your car ignition system and all electrical features and accessories are powered off. Step 4, lock the hood latch using the screwdriver method to trick the vehicle that the hood is closed, because we will still need to work under the hood. Finally, step 5, close the vehicle's doors and lock the car with the key remote. This ensures the vehicle can go into sleep mode. Please note, a vehicle can take up to 60 minutes to go into sleep mode. So this is our low amperage clamp. This is a 40 amp clamp. What we're going to do is go ahead and turn it on. Now it's going to be reading atmospheric electrical pressure. So what we want to do is we zero it. In order to zero it, what I do is I'll tap the clap together 3 times. Okay, it'll still give me a reading. Then I'll press 0 to zero the clamp. It is now zeroed. Now we're actually going to take the clamp and put it on the positive battery cable. And if you notice, it says facing away. So we won't be able to read this from here. So I'll just tell you what our reading is. And I'll flip it around. It'll be in negative, but that's okay, just so you can get a good visual. So right now, the vehicle's computer system is still on. We're getting about 937 milliamps. So we have to wait about 30 or 40 minutes for the car's system to go to sleep so we can check it for parasitic draw. This first method requires you pulling the fuses. So we have our amperage clamp on, and right now there is a draw which is greater than 50 milliamps. We have about 215. So this would indeed cause the vehicle's battery to die overnight. So this method of pulling fuses works, but it's not very efficient because you're going to be pulling tons of fuses, as you can see here on this panel. There's about 30, and also in the compartment where the driver would be, there's actually a lot more fuses. So you can see how pulling fuse after fuse after fuse can consume a lot of your time. Also, the second problem with this method is if you pull a fuse, we could accidentally wake the car up and have to wait the 45 minutes again for the vehicle to go back to sleep. So I'm going to go ahead and pull a couple, and when you see this value drop to 0, that would be one of the causes, or could be the source of our parasitic draw. So I'm going to go ahead and pull one here, and let's see if our value disappears. We'll pull this 10 amp fuse. So we do still have parasitic draw, so that fuse was not the cause. Got to put that guy back in there. Now we're going to pull this 7.5 amp fuse and see, look what happens. So that previous fuse that we pulled actually woke the computer up, so now we actually have to wait another 45 minutes. You can see how this method is not very efficient. So the second method requires you testing voltage drop across fuses. This is a little faster because you do not have to pull the fuses, which generally wastes time. And also, you'll actually be able to see a reading, so that way when you pull out the fuse while monitoring your amperage clamp, you can see the value drop to 0, therefore verifying that that is the cause of the parasitic draw. So looking here on the circuit board, we have voltage on the right meter and we have amperage on the left meter. I'm just going to show you a basic circuit and show you how this theory works before we move over to the vehicle. If you put the positive lead on the fuse on the positive side and the negative lead on the fuse of the negative side of the fuse. So right now with the system de-energized with no power flow, we see our amperage at 0 and our voltage at 0. Now when we energize the circuit, so we have the light on, current flow is going through into the load and it'll drop the voltage after the load. We now see an amperage going through on the left meter, and on the right meter we see our voltage. It's okay if the voltage is in the negative right here just because the way the leads are. So we have about 4.8 millivolts DC, okay? When you turn it off, you have nothing, drops to 0, and when you re-energize, you'll see the voltage. So for example, this is the case where with it energized, this would be your parasitic draw. We see that we have amperage, and we also see that we have the voltage. If we were to pull the fuse, which I will do now, all of our values go to 0. That was the parasitic draw. So this is method 2. What we're going to be doing is we're going to be performing voltage drop across fuses as opposed to method 1 where we would actually be pulling fuses. And if you noticed in method 1 when we did it, we pulled a fuse and it woke the system up. We had to wait, the system went back to sleep, and with our amperage clamp here, we do have parasitic draw, so there is an electrical component or system in here that is drawing power that would kill this battery. So let's go ahead and see if we can figure out what's wrong. So we'll go ahead and start voltage drop probing a couple of these fuses. So we've got this 10 amp one where we have a reading of 0, so that's not our problem. We're going to do this 7.5 amp one, and we actually do have a reading of 2. Let's check one more just to double check. This one's a reading of 0. So this 7.5 amp fuse could probably be our cause. So what we're going to do now is we're going to pull that fuse and we're going to see if our reading disappears. Oh, and if you look, our amperage clamp dropped down below the spec, so our parasitic draw has dissipated. So now what we're going to do is we're going to look at the top of the fuse block here and see which one. So I pulled number 16 here, and I'll point to it, and it's interior lights. So some system for the interior lights here has a light that is on or is energized. So the problem that we found was that these vanity lights are on. So when you open them, normally the lights just automatically turn on. If you can see, I'll fake the switch. These are always on. So this is the source of our parasitic draw. This concludes our video. Thanks for watching, and please be sure to check out our social medias. Until next time.